Okay, now let's talk about the unit number 3, input-output organization. When we started this subject, we started off with a basic block diagram of the computer. If you remember, we had an input unit on the left-hand side of the processing unit and an output unit on the right-hand side of it. The basic purpose of an input unit is to provide the data and instructions to the CPU, which it uses for the processing. The basic task of the output unit is to take the processed information from the CPU and provide it to the user in the format that the user understands. Now, we do not actually talk about the input and output units per se in this particular unit. We are talking about the input-output subsystem of a computer. That subsystem is a way of the CPU to communicate with the various input and output devices. If we talk about the input and output devices, we can categorize them as online and offline devices. The devices that are under the direct control of the CPU, which we can say that the CPU directly controls how they provide the input or how they take the output, or how when they provide the input and when they take the output. Such devices are called the online devices. And there are certain devices which are not under the direct command of the CPU. They are called the offline devices. We'll come to that later on. Now these input and output devices, as they are usually connected to the CPU, they remain at the periphery of the CPU. That's why they are also called the peripheral devices. They may be the auxiliary storage devices like your magnetic storage, your optical storage, your flash storage, your thumb drives, your pen drives, and all those things. They are all input and output devices, or we can say that they are all peripheral devices. If you would like to list up some of the peripheral devices, we have the input devices, which I'm sure you're all very familiar with: the keyboard, the touchpad, the mouse, the joystick, the light pen, and things like that. Nowadays, most of the laptops that are coming, the new laptops, they're all coming with touch screens. Output devices, when I talk about output devices, the most commonly output devices that come to your mind are the monitors, the printers, the plotters, the speakers, right? Monitors, earlier we used to have CRT machines, CRT, cathode rays tube monitors, which were used to be very bulky and very heavy to transport from one place to another. Now we have such beautiful slim LEDs and LCD devices. So these are all some of the peripheral devices. In this particular unit, we are not focusing on what are the various input and output devices. We are not going to talk about how a keyboard works, how a mouse works, or how a joystick works. We are basically going to talk about how your computer is communicating with these input and output devices. This becomes important because when we use any input or output device, if you remember, most of the input and output devices that we use, like the keyboard or the mouse or the touchpad, we do not need to install any specific software for using these devices. But even today, with our latest machines and latest operating systems, if I want to use some specialized input and output device, I need to put in a driver for that particular device. Now, whenever I'm connecting such an input and output device to my machine, I connect it to a specific port. Now, that port becomes the hardware part of the interface that is used to communicate with the input and output device. So there is basically a communication that is established between the CPU and the IO device. That communication is established with the help of two components. One is the hardware component, which is basically the port where I'm connecting the hardware device. And second component is the software component, which is specified, which is made up by the device driver that you have to install before you can use any specific, any specialized input or output device. The modern computers, you can say, we have a common system bus wherein all the processors and the memory and the input and output devices are connected. This is the basic idea of a computer, which is having a number of devices connected together. This, as you remember from the second unit, you might remember from the second unit, this is the system bus which we talked about. This is a system bus which is used to connect the CPU to the various components of the computer. We have the processor over here, we have the memory over here. Memory, if you remember, this is the primary memory, the RAM and ROM. Then we might have certain input devices, we might have certain output devices, and all of these devices are connected to each other through this system bus. Now, if we make this a little bit more elaborate, we have the processor and we have the input and output bus. Now, any bus, as you might remember that we talked about earlier, is essentially having three types of lines on it. One is called the data lines, one is called the address lines, and the third one is called the control lines. Data lines for the data to travel on it, address lines which essentially carries the address, and the control lines which essentially carry the control signals. Now, these are the various devices, the keyboard and display terminal, the printer, the magnetic disk, the magnetic tapes, and all those things. These all devices are connected to the I/O bus, which is connected to the processor through their individual interfaces. Now, this interface is, as I've told you in the earlier slides, this is made up of a hardware component and a software component. Let's talk about why we need this interface. What is the requirement for this interface? If you try to think about the CPU on one side and the various input and output devices on the other side, these are the two things that are going to communicate with each other. Now, they have some marked differences between them. The CPU is primarily a semiconductor device. Whereas if you talk about the input output devices, we may have an optical device, we may have a magnetic device, we may have a thermal device, we may have a electromechanical device, or we may have an electromagnetic device. So there are marked differences in the construction or in the design of the CPU and the input output devices. Then the data transfer rate. We all know CPU is quite fast as compared to your input and output devices. CPU transmits the data or accepts the data at a much higher rate as compared to the input and output devices, whereas the CPU or whereas the peripheral devices are quite slow. Another important point being the unit of information. The CPU basically talks in terms of word size. Whereas when we talk about the peripheral devices may be communicating in terms of bytes or bits or even records or tracks or sectors. Now, the point that I want to make over here is there are specific marked differences between the CPU and the peripheral devices. And they will not be able to communicate with each other effectively unless and until we have some component in between that is going to translate one language to another, the language of the CPU to the language that is spoken by the input and output devices. That task is performed with the help of device interface. Now I'll give you a couple of seconds to just look at this diagram. This is the basic idea of a device interface. There are certain components in the next coming slides. The use of all these components will become more clearer. But just to name a few, we have the decoder component, we have the control component, we have status component, and we have the buffer component. These four components essentially make up the device interface. Here we have the device and we have the transducer. For those of you who do not know what transducer is, a transducer is a device that converts one type of signal into another type of signal. Say for example, when you click any key on your keyboard, that particular clicking is converted into an electronic signal with the help of a transducer. When I'm moving my finger on the touchpad, that movement of my finger on the touchpad is getting converted into the movement of this particular laser indicator with the help of a transducer. Let's talk about what and how this device interface actually works. Let's continue. Now, each peripheral device that is connected to the CPU, may it be the keyboard or the mouse or the touchpad, any peripheral device that is connected to the CPU, has an interface unit that is connected to it. Now, this interface unit is used for communication between the CPU and the input and output device. It is basically bridging the differences that exist between the CPU and the input and output device. It is also supervising the data flow between the CPU and the input output device. It is synchronizing the clocks between the input and output device and the CPU. Each and every device that we are using on your computer, may it be the touchpad or the keyboard or the mouse or the monitor or the speaker or any other input output device that you are using, any peripheral device that you are using, Each and every device has its own interface. Let's see how this interface actually works. Now, these are the two diagrams that we have already seen. I've just put in again once over there. Let's talk about the entire input-output process. Now, the input-output bus from the processor is attached to all the peripheral interfaces. As I've just told you, that this is the input-output bus, which is made up of three types of lines. One is the data line, one is the address line, one is the control line. Now, these are connected on one side to the processor and on the other side to the interfaces which are connected to the various input-output devices. Now, when the CPU wants to communicate to a particular device, what it does, it takes the address of that particular device and puts that address on the address lines. Now, there may be a number of input-output devices that are connected to the I/O bus. Now, each and every input-output device is identified with the help of a device address. Now, whenever the CPU wants to communicate to a particular device, let us say the CPU wants to communicate to the keyboard. Let us assume that the keyboard is device number 1, and let us say the mouse is device number 2, the touchpad is device number 3, and so on. So when the CPU wants to communicate to, let us say, the keyboard, what it will do, it will take the address of this particular device, which in our case is address number 1, and puts this address on the address lines. Now the address that is put on the address lines is read by the address decoder section of the interface. Each and every interface has an address decoder section. Now what this address decoder section does, it reads the address from the address lines and uses it to decide whether the CPU wants to communicate to this particular device or not. Each interface knows the address of this particular device. Now, when the CPU is placing a particular address on the address lines, this address is read by the decoder, which uses it to decide, which uses it to identify which particular device the CPU wants to talk to. Now, there may be two cases. Number one, the address that the CPU has put on the address lines might be for the device that this interface is controlling, or it may be the address of some other device. Now, when the interface detects that the address that has been put by the CPU on the address lines is for the device that it is controlling, it activates the device. Otherwise, it simply deactivates the device. Right? So, depending on the address that the CPU has put on the address lines, the device is either activated or deactivated, and that task is done by the decoder section. Next, at the same time, what the CPU does, the CPU puts a control information. A function code is placed by the CPU on the control lines. Now this control function, this plays a very important role because it is this control function that is actually controlling the entire input and output process. Now this function that is generated by the processor is received by the this section of the interface, and the interface then executes this function. Now this function is essentially accepted in terms of an input output command, right? There are essentially four types of input output commands that are accepted by the interface. They are classified as control, status, data output, and data input. Let's talk about these. Now the control command is used to, as I've just said, that there are essentially four types of commands. One is the control, one is the status, one is the data input, and one is the data output, right? Now the control command is used to activate the particular peripheral. Now when the CPU issues the control command, it is received by the control component and it is used to activate the device. Say for example, if we are talking about a magnetic tape unit, then what happens is the control command may initiate the tape device to start moving in a particular direction. We may want to move it in the forward direction, or we may want it to move into the backward direction. Then this particular control command, Now, what will be the function of this control command will depend upon the peripheral device, the particular peripheral device that for which the control command is emanating, right? Second, the CPU may issue a status command. Now, before any input and output operation can actually take place, the CPU has to know the status of the device. The status of the device may be whether the device is ready for that input output operation or not. If we take certain examples, if let us say I take the example of a printer, the CPU might want to know whether the printer has toner in it, whether the printer has paper in it before the CPU is actually sending the information to the printer to be printed. When the CPU is reading some information from the keyboard, the CPU might want to know sorry, has the keyboard actually put in a particular character in the buffer before it starts reading the data from the keyboard. So the status command is actually used to check the status of that device. Now see, as you can see from the direction of the arrows, the control command is coming from the CPU and it is going into the device which is used for activating the device. Whereas this status information is actually going from the device to the status register, and from there it goes to the CPU. The status information is going from the device to the CPU, right? Then once the device has been activated, once the status has been ascertained, when the CPU judges that the device is ready for the input output operation, then it comes for the actual input output. Now there may be two cases. One is the data output, one is the data input. See, we are talking in terms of the device. Sorry, we are talking in terms from the point of view of the CPU. When I say data output, what I mean is the data output from the CPU to the device. When I say data input, I'm saying data input from the device to the CPU, right? The data output command, what data output command does is the lines that the information that is generated by the CPU is placed in the buffer. From the buffer, it is converted into a form that is understandable by the device with the help of the transducer, and from the transducer it is passed on to the device. On the other hand, what the data input command does, once the computer has ascertained that the status of the device is well, that the device is ready to give me the input, then the device generates some input which is converted into the form which is understandable by the CPU with the help of the transducer. It is then placed in the buffer, and from the buffer the CPU reads the information. So this is how the typical input output interface works. Now, if you have any doubts on this, we will meet in the session that I have talked about, that I have scheduled the session with your class through that WhatsApp group, and I'll solve all your queries over there. Thank you.